Hey, welcome back. So this section has been all about errors and handling them, identifying them, raising our own. But now we're going to talk about the other side of the coin, which is when we encounter an error in our code that's not intentional. So we didn't raise it, we didn't expect it, something's not going the way we want, whether it's a very loud, angry error that's actually printing out an error to our terminal, or a silent error, meaning, or a silent bug, is what more likely you would hear it as, meaning that something isn't working the way we expect, but it's not actually breaking the code. So that's the most frustrating, is when you have code and you expect it to work one way and it doesn't break, it just gives you a different result. The tool I'm going to introduce, called PDB, will actually help us understand our code and step through it to figure out where we're going wrong. So PDB stands for Python Debugger. It's a module, just like random, that we included earlier on in the course, that we have to manually import in our code with a single line, and then we have access to it. So we don't have to install it or anything. And then by importing it, and then there's a single method that we'll call, which will pause execution of our code. It looks like this, pdb.setTrace. That, wherever we put it in our code, on line 1 or on line 100, when Python encounters that line, it will pause. So it doesn't quit, it doesn't skip everything else, it pauses. And then in our terminal, we can go and interact with values, or we can step through one line at a time. So enough of explaining it, let me just show you. Here I have a really simple file, and we're not going to debug something, mysterious that we're not sure what's happening. This is super simple. I have two variables, both strings. I'm adding them together into a third variable. Then I make another variable, actually called third, and I add that into result, and then we print result. So nothing groundbreaking, but we're still going to use it as just our starter debugging code. So the first thing we need to do if we want to use PDB is import it. And we've seen how to import code. We saw how to import random in the rock, paper, scissors section. So we import a module just by name, import PDB. And then the magic line is this right here, pdb.setTrace. And 99.999% of the time when you work with PDB, at least when I do, this is what I use. And we put this wherever we want. If we actually had something that was breaking, I would put it right before the line or the couple lines where things were breaking. And then that allows you to see a preview of what happens before and then step through it and then step after it. But for now, let's just put it let's go right here. So we're going to define first and then second and then stop. And when I run this file, Python's going to get to here and it's going to stop, and then I'm going to be able to go explore. So it opens up this new shell for me to start typing in. And the only other thing I'll point out, there are some commands down here, and we'll talk about these in just a second. But first, let me just show you when I run it. So this file was called debugging. Okay, so look what happened. Result equals first plus second. This is telling me this is the next line that it's waiting to execute. And going back to these commands here, there's this command L I can type in. And if I type L, you can see PDB. So normally we run a Python file and it executes. Maybe it will ask us for input or something, and then it's done and our prompt goes back to normal. That's not the case here. It's waiting. And I'll type L, which stands for list, which will show me where I am, sort of like a map. And so it shows me that basically this is the last thing to run, and the arrow is pointing to what happens next. Okay? So it's showing us that this is next. And what I can do now is explore some of the values. So for example, if I type first, you can see that it has a value. It's set to first. If I type second, it has a value as well, which is second. That makes sense. But if I try and access a variable like third, it's not yet defined because this line hasn't been run yet. Neither has this one. So if I tried result, same thing, name error. So if something was going wrong with this code, this is exactly what I would do. I would set trace somewhere, and I'd check variable values before. I'd look at, result, okay, it doesn't exist yet. And then I would use the PDB command to move to the next line to actually execute this line, and then pause here. And then I would look at the value after that line executed. And the command to do that, it's in this file, it's n, next line. So if I type n, look at where the arrow is right here, or just this is the next line to run. I type n, and the arrow has moved down. If I type L again for list, we can see this line has run, and we're waiting on this one next. And if I type result, it now has the value of first, second. So by the end of this code, it will have first, second, third. So, and also if I look at the value of third, it's still not defined. This is the last thing to run, so I can step through with n again. And now if I look at third, it's equal to the string third. First is still the same, so is second. Result is only first plus second. But now if I step through one more time, you can see result now should be equal to first, second, third, and it is. And then the last thing to happen when I execute this is for print result to run. And so I can hit N again, and then it prints result, which is what we get right here. So hopefully you can see how this is useful already. I should mention, to get out of here, you can use the command Q to quit, and it's really not graceful. It basically like throws a wrench in everything and gives us an error message. That's its way of quitting. So there's another way of quitting if I rerun this, which is, it's kind of counterintuitive. The C command, which stands for continue, which seems like the opposite of quit, but it actually just means continue with the rest of the code. So if this is where we paused, just continue with everything afterwards. And then that will, in a split second, execute our code and we'll be done. And it won't quit out with that hideous message. So I type C and it runs everything, which only prints first, second, third. That's really all that happens in our code. And then we go back to normal. We're out of that PDB world. One other thing of note about PDB, if we had some code that looks something like this, and I'll just paste it in and comment this out. The first thing I'll point out is that most of the time, at least when I use PDB and a lot of other developers, we'll just do it on a single line, import PDB, and you need a semicolon here, otherwise Python freaks out because it thinks this is all an import. So this is a way of doing multiple lines on one line. Import PDB and then use it. And the only reason for that, we'll talk more about imports in the module section. I should have mentioned that earlier in this video. Don't worry about modules for now. But the main reason is that really this is usually in my code for 5 minutes, 10 minutes, an hour, however long I'm debugging something, and then I get rid of it. It's not something you keep in your code with all the other import statements up top. So it's usually used like this. Okay, but the main point I wanted to make here is that if I have variable names like A, B, C, and D, and I save and I execute this, where I'm setting trace here, and let's say that I'm calling add numbers 1, 2, 3, 4. Okay, let's go back over here. I run it now, and let's look where I am. So we're returning A, B, C, and D, and if I try and access the values, like if I type D, for example, I get this newest frame, or if I typed A, this is giving me basically all values, I believe is what A stands for. It's not actually giving me the value of A itself. If I type B, I don't think that's a command. If I type C, that is a command, right? That quits out, as we saw earlier. So if you have variable names that conflict with the commands, like L, if we had a variable named L, then anytime I typed L, it would just list things instead of giving us the value of L. So instead, what we can use to print the actual value, let's say of C. I don't want to quit. If I type C, it would quit, or continue, which would effectively quit. I can type P, which stands for print. So print the value of C, and we get 3. Print A, and I get 1. Now, A, B, C, and D are terrible variable names, so it serves you right if you use those as variable names, but just beware anyway that if you are using single letter variable names, they may conflict with existing PDB commands. And I showed some of them here. These are the ones I commonly use, but there are more out there. For example, A, as we saw. So just be careful with your variable names, and if something weird happens in PDB and it's not what you expect, check the name of your variables. You may have a conflict with an existing command. All right, so that kind of wraps up what I wanted to cover in this video. We import PDB, run pdb.setTrace, that halts execution. One thing I should mention, in this example, we have a function defined, and pdb.setTrace doesn't actually run until we execute the function. So Python goes over this and is like, oh, this is a function that's not being executed yet. It's just being defined. So I'm not going to run So hopefully that makes sense. Otherwise, if it ran right away and I tried to access A, B, C, and D, there would be no values assigned to them. So that's PDB, short for pretty dang beautiful, pretty dang bamazing.